Hello everyone, myself Mohammad Barid. Today I am going to present on gVisor enhancing container security. gVisor provides a robust layer of isolation between application and the host operating system. It is an application kernel that implements a Linux-like interface written in Go for memory safety and running in user space. Basically, in modern cloud computing, containers are widely used for deploying application because they are lightweight, portable, and fast to start. Companies use containers to build microservices, cloud native applications, and serviceless platforms. However, containers shares the same host operating system kernel. If a container is compromised, an attacker may exploit kernel vulnerabilities and gain access to the host system. To overcome this majority security risk, Google introduced gVisor, which acts as a secure sandbox for a container and provides an additional layer of isolation. So gVisor helps organizations run containers securely in multi-tenant cloud environment. In this video, we will know about what is gVisor, what does it do, and why choose gVisor. Gvi- uh, what is gVisor? gVisor is a open source application kernel deployed by Google and written in Go programming language. This is the basic definition of gVisor. What does it do? Implements a large portion of Linux system call interface in user space. This means application thinks they are communicating with Linux, but actually they are communicating with gVisor. What does gVisor do? It intercepts and handles system calls. It sandbox applications. It prevents direct mm, access to the host kernel. Oh, why choose gVisor? Why go for gVisor? Because it provides a strong isolation than traditional containers and is ideal for running untrusted workloads such as third-party application, customer code, and serviceless functions. How gVisor differs? Traditional virtual machine uses a hyperservice and virtual hardware to provide isolation. They are secure but consumes more resources and have slow boot times. Traditional containers uses namespace and C groups for isolations but still depends on host kernel. gVisor provides a third approach. It does not use VM virtual hardware. It does not expose the host kernel directly. It acts as user space kernel. This gives gVisor VM like security with container level efficiency. In fourth slide, hmm, we will learn about gVisor's unique architecture. gVisor intercepts application system calls acting as guest kernel without virtualized hardware. It provides a VM-like security with a lower resource footprint and faster startup with potential compatibility and overtrade off. gVisor has a unique architecture built around user space kernel. The main component is called Sentry. Sentry implements Linux system call behavior and acts as virtual kernel. Hmm. Another important component is gVisor, which securely handles file system access. Instead of using virtual hardware like virtual machine, gVisor intercepts system calls and emulates kernel behavior in user space. The significant reduces the risk of kernel exploits and containers escape attack. In this slide, we are looking at core components of gVisor. There are mainly three core components: Sentry, gVisor, and Run SC. Let's go with Sentry. Sentry implements Linux system calls, process management, memory management, and networking. What is gVisor? Provides isolated file system access containers, acts as a file system, and controls file access between container and host. Run SC The OCI runtime that allows gVisor to integrate with Docker and Kubernetes. These components together from a secure container runtime environment. Let's look at this system call flow in gVisor. How does the system call flow? Mm, there are total 5 components in system calls: application calls, entry intercepts, validation and processing, host interaction, results, returns. Let's see what how this works. When an application makes a system call, instead of going directly to host kernel, it is intercepted by gvisor. Then Sentry validates the request, checks permissions, and processes the call. Some calls are handled completely in user space, while others are forwarded in a controlled manner to the host kernel. This design reduces the kernel attack surface and prevents malicious application from exploiting kernel vulnerabilities. Let's take a look at slide 7. mm, gvisor versus traditional containers. In traditional containers, application run on the host kernel using namespace and C groups. In gvisor based containers, application interacts with Sentry instead of host kernel. This provides better isolation, improved security, reduced risk of kernel exploits, safer multi-tenant environment. So gvisor is widely used in public cloud platforms and serviceless environments. What are the strengths of gvisor? gvisor provides several important strengths: strong security isolation, reduced kernel attack surface, compatibility and ease of deployment, open source and industry backing. Strong isolation through user space kernel, reduce kernel attack surfaces, compatibility and ease of development, open source and maintained by Google, supports Docker and Kubernetes, ideal for untrusted workloads, improves security in multi-tenant environments, compatibility with existing container workflow. These strengths make gvisor suitable for cloud native security architectures. L- Limitations and challenges. gvisor also have limitation and challenges. Despite its strength, gvisor also has some limitation. What are those? Mm, Performed overhead, partial system call support, debugging complexity, additional resource consumptions. There is performance overhead due to system call interception. Not all Linux systems call are fully supported. There is a higher CPU and memory usage. Debugging becomes more complex due to additional layer. Because of this, gvisor is best suited for security critical application rather than performance critical system. So conclusion: gvisor's role. To conclude, gvisor plays a crucial role in enhancing container security. It introduces a secure sandbox layer between application and the host kernel. It protects cloud infrastructure from container escape attacks. It is widely used in cloud platforms where strong isolation is required. Although it introduces some performance overhead and security benefits, make it a valuable solution for modern cloud environment. So gvisor is an important technology for building secure cloud native system. Thank you.